All right, introduction to statistics. This first section and the first couple sections just give a lot of definitions, but they're definitions that you got to know throughout the year. Otherwise, you won't understand all the stuff that we do after this. Section 1.1, and again, I wouldn't write all this stuff down. I'm going to go through it because this is what they tell me is the best teaching practice to teach you, is show you the objectives. What are you going to learn today? Every teacher does this, right? They tell you, oh, we're going to learn this, we're going to learn this, and we're going to learn this. Well, that's what I'm supposed to do. So this is what we're going to cover today. Defining statistics, distinguish between a population and a sample. Anybody have any idea before we go on what's the difference between a population and a sample? Make a guess. Okay. Okay, sort of. That's it right there. Easiest way to distinguish between the two, population, everything. All right? Now, a lot of times we won't be able to deal with populations because if I wanted to do a census, like they do the census every few years, and your parents are probably doing this by their door when the census taker comes up and not answering, they're looking out the window, not answering the door. You ever do that? It's not as bad as it used to be because now they get you by sending it online and stuff like that. But it's about impossible to get an entire population. All right? Even if we were going to try to do the whole population of the National Trail, is there ever going to be a day when every student is here? No, it doesn't happen. All right? A sample is me just picking certain ones out. And there's different kinds of samples, and we'll talk about those as the year goes along. Distinguish between a parameter and a statistic. That's something that we'll talk about. That was probably some of the stuff that you might have, if you looked at the assignment, you might have had trouble with that. Distinguish between descriptive statistics and inferential statistics. This one you can probably sort of think, and you know math people aren't creative. All right, they don't make up stuff. Does anybody know what descriptive means? Don't tell me that. You guys are juniors and seniors. I know you got to know what descriptive means. Say it. Okay, detail about whatever you're talking about, right? What's inferential? This one's a little harder. A lot of times students don't know what inferential means. What's an inference? All right, and that's what we were talking a little bit about last time, about insurance and you guys, and how they probably rip a lot of you off because their inference is that Carson's going to wreck at least twice before he turns 21. All right, and so they jack up your insurance by them. See, Grant's laughing because he's wrecked about 6 times now. He's taken up for those of you who don't wreck. What is it? 7? I hear that from teenagers all the time. Wasn't my fault. All right, data. And I'm just going to put these up here. There's like 4 definitions here. Again, don't write down the whole definition. Write down what you need to write. Shorten it up. Do something to make it easier on yourself. Data consists of information coming from observations, counts, measurements, or responses. So data is just what you collect. You probably know what data is from science class and different things. You collect certain things. You get it from either just counting, observing something, measuring something, or maybe on a survey, the responses on the survey. Statistics, with an S on the end, that's what this class is called, is the science of collecting, organizing, analyzing, like this right here, this definition, as I'm reading it. Do you really need to know the definition of statistics? Probably not. That's what we're going to be doing all year long. So just know, hey, it's like taking a math class. When Nick took geometry, did he have to write down the definition of geometry? Not really. Maybe he's going to be in that class all year long. But it's just the science of collecting, organizing, analyzing, interpreting data and making decisions based on that data. Population. Dalton gave us sort of the definition of population. Population is what? How could I shorten up this definition for population? One word in this whole thing, you could write it down, and that would probably tell you enough. What's one word in this definition? Is all. So if I wrote population, everything. Sample, instead of everything, sample is what? Piece of it, part of it. It's that simple. They say they got to be real mathematical, so they say it's a subset. Trying to be real intelligent sounding. Just got it up there, I guess. That's what old lady said. Jesse, you probably don't know, but I was talking to somebody the other day. Don't the Schaefers own all that land out there in that area?
Where I live?
Well, on where your grandpa lives and where all of the...
Around me and my grandpa, across the street, right there. My uncle, my great uncle owns all of that.
All of it.
But
I don't know, I was talking to somebody and they were saying that, I can't remember his name now. One of the Schaefers, and he was telling my aunt that he just paid off his house. I thought,
yeah, that was Alan.
Alan.
Probably. But
I thought the Schaefers own all that. They've always owned all that.
now Lauren Schaefer, he used to own like everything, and New Paris and all that land.
Yeah, I worked for Lauren
Yeah.
for a couple of summers.
Yeah.
He was sort of a knucklehead sometimes.
Yeah, I work for him still now around his house and stuff. And
He likes to get all out of you, doesn't he?
I think he's hilarious.
He's
What he says.
Well, he's probably a little older now, but when I was working for him, he said, I'll pay you, I can't, it was like $25 a day. And at that time, I thought, I know it was $30 a day. I thought, okay, that's all right. You know, 8 hours divided into 35, that's about $4 or $5 an hour.
Yeah.
So I thought, yeah, it's not bad. That's, you know, about what I made bailing hay or whatever. Well, that 8-hour day all of a sudden turned into a 12-hour day the farther we went along. I'm like, this isn't worth it no more now. 12 divided into 35 or 30, whatever, it's not worth it.
I remember I worked for him, I didn't even come up with the price, he just goes, I'll pay you 15 an hour. And I was like, I don't know, say that.
Must be because you're related to him, but I wouldn't. Right, you've already got this down, so just going over this data consists of information coming from observations, counts, measurements, responses. If we look at this sentence, people who eat 3 daily servings of whole grains have been shown to reduce the risk of stroke by 37%. What's the data in that? Don't be afraid. I know I called Riley an idiot the last time she gave a wrong answer, but I won't do it this time. That was a joke, just in case anybody's watching this video and getting in trouble. What's the piece of data in this? 37%, all right? 70% of the 1,500 U.S. spinal cord injuries to minors result from vehicle accidents, and 68% were not wearing a seatbelt. What's the pieces of data in this one? Here, you got to be a little careful. There's actually two of them. That's the data. What is this 1,500 of those things that we talked about? Population. All right? And that's where you have to be careful, because when you start throwing in all those numbers, then it's statistics. We're just going to skip over that. Population, the collection of all outcomes. Again, it's hard and almost impossible to do a population unless you're just working on, let's say we're going to do, and we will later on in the year, do the population of students who take statistics at National Trail. Well, that's pretty easy for me to do because there's 16 or 17 of you, and I can do that whole population. All right? But if we're going to do the population of all females in the United States, then it's not going to work. It's going to be too hard to get everything. A sample is a subset of that population, so you got your populations, all these people. Sample is just certain ones that you pick out. There's different ways to pick those. We're going to talk about that later on in the year. Part of the assignment, I think part of the assignment was to decide whether something was a population or a sample. I think probably through there. In a recent survey, 250 college students at Union College, that's the college I went to, were asked if they smoked cigarettes regularly. 35 of the students said yes. Identify the population and the sample. You really got to be careful here.
250 population.
The whole college. They don't give you a number for the whole college, so it's sort of really tough sometimes to pick that out. But the whole college, every student at that college, however many of them there are, is the entire population. And then what's the sample? The 250 is the sample. The 35 is our actual data. All right? That's what we counted, or what we came up with. So Union College, the whole thing, this big box here, is the population. And then our sample is the 250 students who actually responded. A lot of times when you take a survey like this, and you're asking some 18-year-old student that's a freshman in college if they smoke regularly or not, are they going to tell you the truth? No, they're going to lie. All right, so, and maybe they won't even respond to it because they don't want their folks to find out. Identify data. Identify the data sets. In a recent survey, 1,708 adults in the United States were asked if they think global warming is a problem that requires immediate government action. 939 of the adults said yes. Identify the population and the sample. Describe the data set. What's the population this time? Adults in the United States. Sorry that you guys get left out unless you're 18 already. What's the sample? 1,708. Remember last time we talked about crazy fractions and how we're probably not going to write stuff as fractions. Well, this one here, it says that 939 said yes. So if I do this, that would be 939 out of 1,708. If I put that fraction on something and said, yeah, this many people said that global warming's a problem, Most people gonna have a clue what that tells them? No. So what would we probably wanna do with that fraction? They did it on all the other ones. Change it to a what? Percent. All right? Divide this and change it into a percentage, and that'd make more sense. You'd say 53% of people say that global warming is a problem, whatever that comes out to be. All right, so the populations, all the adults in the U.S., sample consists of 1,708. Because you can't when the pin's on, so I need to turn the pin on. Come on, Grant, sometimes I know what I'm doing.
All the time.
All right, a parameter, and this is a little harder. A parameter, and I'll just put this next one up. Parameter and a statistic, in 50 seconds. And you could probably, the definition of a parameter, you could probably use 2 words for the definition of a parameter. Maybe 3, because we might want numerical in there. And probably 3 for a statistic. Notice no S on the end of that. Statistics is the whole class. Statistic is something different. Nick, Jacob, you guys do a bunch of the band stuff, don't you? You don't do none of the band? You were in the band? You're not really? Were you in the band before? You quit now? Okay. My son's supposed to quit when they got to about your age too. If you were like me, that would never get old. I wish I could play some kind of musical instrument now that I'm older. YouTube. My wife knows how to play the piano, and she tried to teach me. Lasted about 2 lessons.
Yeah, that sounds hard.
She said, I'll learn this. She gave up on it. Jacob, you still do all the band stuff? No good either?
No.
Did you guys all quit because Mr. Ross left? Huh?
Pretty sure he will.
Is that what makes it good? So he was mean to you? Sound like Mr. Ross. I was gonna tell you guys you need to keep him here. I don't know, how does this, anybody do anything with band? How's this new one? Nobody knows. All right, a parameter. A parameter, and the 3 words I would use for a parameter: numerical description of the population. So if you just wrote that down, so it's some kind of number that describes the population. 42% of all U.S. citizens own a cell phone. It describes the entire population. It's a number that describes the whole thing. So, statistic is a numerical description of a sample. So, normally we'll be dealing with a statistic and not a parameter because we can't, a lot of times we can't get the whole population. This might be an easier way. If you write this down, see, this is something I added myself. I'm such a genius math person. Parameter goes with population, statistic goes with sample. So anytime you have a sample, you're dealing with a statistic. Anytime you have a population, you're dealing with a parameter. Parameter and statistic are the same thing, just one goes with the population, one goes with the sample. See, your head's starting to feel better because you put this on in. Parameter, and don't write any of this down. When we get to these examples and stuff, don't. A number of, that describes population characteristics, average age of all people in the United States, that would be a parameter. Statistic, number describes sample characteristics, average age of people from a sample of 3 states. Now, probably are we ever really going to be able to figure out the average age of the entire population of the United States? No, by the time we get done collecting all that data, what's going to happen to the ages? It's going to change, because we're going to go out here and it's going to take us, I'll get those here. It's going to take us 3 months to survey everybody in the United States. What's going to happen in that 3 months' time? Everybody's age changed a little bit. People die and people are born. So all of a sudden now we got to go back and start all over again and redo it all. Right? So normally, if we were going to deal with something like that, it'd be a statistic. We'd go out and we'd say, all right, we're going to pick 5 states and just do those states, get the numbers, figure out what the average age is, and we're going to say that that's close enough probably for the entire country. Now, what would you not want to do when you're out there picking? This doesn't have anything to do with this really, but when you're out there picking those states, how could you pick them? Maybe. All right. Do we just want to come up here and like pick 4 or 5 states right up here in this area? How about in this area over here? How about this area right here? Probably if you just take one area, there's probably going to be other factors that are involved there, right? And I have no idea, but I would guess that the average age in Florida is probably a little higher than the average age in North Dakota. Why might that be? People are retired, go where? They go down to Florida and live. So if we go down there, the average age might be 58 or something. North Dakota, usually people don't move to North Dakota to retire. Decide whether the numerical value describes a population parameter or a sample statistic. Recent survey, a sample of MBAs. Everybody know what an MBA is? That's what you're going to get in a couple of years, right? A few years. Reported that the average salary for an MBA is more than $82,000. They sort of tell you right off the bat. Is this $82,000, is that a statistic or a parameter? What's the key word in here that tells you the answer? Sample. If it's a sample, then this has to be a statistic. If it's a sample, that's got to be a statistic. Starting salaries for the 667 MBA graduates from the University of Chicago Graduate School of Business increased 8.5% from the previous year. So it's 8.5%. Is that a statistic or a parameter? What are we dealing with here? We're dealing with a population or a sample? Because this is all the people that graduated from there with the MBA, right? So it's a population, so that's a parameter. Sometimes we can get the entire population when you're looking at something like that, just a some certain group. Recent survey of a sample of 450 college students right away. What can we stop and know? It's a statistic. The average weekly income for all all students is $405. That's a parameter because it says all, how they figure out that that's all students, how they got that, I have no idea, because that seems like that'd be awful hard to do. If they said all students at National Trail, then I could say that, but all students in it. Study of statistics has two major branches: descriptive statistics, inferential statistics. You might just maybe draw these little boxes is what I do, and maybe here in a second, you write down a couple things about each one. Don't make it harder than it has to be. You know, I know Michael enjoys writing down all these notes that I give him all the time. Right, Michael? Don't lie. Boy, that's hard to see. Can you read that purple box? Don, did you play baseball anywhere over the summer? Did you play for?
Greenville.
Greenville. Do I? What age were they playing at? Is that just an unlimited? 19. Play tournaments around here.
Kind of around here.
Play some of those like things that they showcases.
Yeah. Never fun.
Some good teams in it, wasn't there? Yeah, we went there, got our butts kicked a couple times.
We went up to, they had like a showcase up in Pickwood. They had it. There was like 35 teams in it. Oh my gosh. Triple, those like triple elimination nights. They had 5 brackets. We got maybe 2 games into it. We played 4 of them. It wasn't fun. First game we got beat by like 15 times. 15 balls. We were pitching Billy and everything too. Like, they're ace sometimes.
I played in one tournament, had 45, I think, in it, and one that had 42 in it. One of them they did pretty well.
It's just, like, the level that they play at is nowhere near the level that we play at, like, in our league. So it's like,
I try to explain that to everybody. I try to explain to my son too. Last couple of years he played for a team, and that coach tried to schedule stuff that they would win. So like 2 years ago, their team went like 50-7 over the season or something. I'm thinking this isn't teaching my kid anything. That you can beat up on some of these other teams do. You know, sometimes you gotta go play competition. You got the competition this year, then kids go like, all right, statistics. Again, notice the S. That's all of it. That's everything. In statistics, we have 2 different types of statistics. Descriptive. And again, what's descriptive mean? What's it do? Give me some description of yourself. Mr. Miller, give me a description, a word that describes you.
I don't know.
That's not a word that describes you. Make up something, let's go. Come on, you can describe yourself. One word.
One word.
What? What'd he say?
White.
Like. Alright, descriptive statistic. See now, I'm giving you the chance here to say something like handsome, stunning, debonair, something like that. He doesn't even use those words. Alright, so that's a description. 17, that's a description, if that's how old you are. 16, 18, however old you are, that's a descriptive statistic. Now you gotta be careful with some of them, because a lot of times with the descriptive statistic, we think of just like eye color, hair color, height, but sometimes they're numbers, and you gotta know that that number's not really telling you anything. It's just saying this person is 17. It's not saying that somebody that's 17 is better than somebody that's 16, right? So it's not something along those lines. Descriptive. Inferential. Inferential statistics. What do we say an inference was? Like a guess. All right, we're going to infer something. I'm going to infer or guess that here at 8:52 the bell's going to ring and everybody's going to run out the door because they're bored with you. All right? That's an inference. I know it's not true because Sean over here, he stays behind because he likes me so much and everything. So an inference is where you say, I think this is going to happen. I'm getting ready to go back towards you guys on my insurance plans for my cars. So here, the other day I was making fun of Dalton about his insurance being so high, and I pay that for a year. And I'll come back and visit me next year, Dalton, and my insurance will jack up there. How come?
Your kids.
They're already on there. It's just because of me. Why is your insurance so high? What's going to happen with me? I'm getting older. So now what are they going to do to my insurance? They're going to jack it up.
Just don't hit the little post at the gas station. How many old people hit these things?
Probably Grant knows about it. That's probably one of his 7 wrecks. Isn't it? All right, descriptive statistics involves organizing, summarizing, display of data, tables, charts, averages, so on, descriptive. Inferential is when we take this group and we do some kind of survey and we say, look, 1 out of every 3 people that live here is black. And then we infer that on the group and say every 3rd person we see is probably going to be black, right? That's an inference. Now, does the inferences always work? No, we've already discussed that you know, you're 16, 17, 18 years old, you might never have a wreck. But the insurance company's charging you like you're probably going to have a wreck. Descriptive inferential statistics decide which part of the study represents descriptive branch. What conclusions might be drawn from the study using inferential statistics. A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately, some of the young ladies are probably going to take offense to this, approximately 70% were alive at age 65. For married men, 90% were alive at, I don't know, I guess it wouldn't take offense to this. Were alive at age 65. I was thinking it said the other way around. What? So it would make sense if it was the other way around? That you live longer if you're not married? Yes. Maybe you get like me and I'm going to live forever just to spite my wife so she's got to get all the insurance money and stuff that she's got on. So she's got about 6 insurance plans on life insurance plans. What's the descriptive part of some of this? Give me something that describes something in there. Age. 18, 65, so on, so on, so on. What could we infer from this? What's this study sort of telling us? Make an inference about something. Make a guess about something.
All men live longer than married.
All right, married men live longer.
Maybe when
So, if you're a young lady, then that's probably what you say, hey, look at this study, you guys need us. We don't need you, but you need us. Huh?
I told her, I figured 40.
Alright, so descriptive, the percentages were, the ages, possible thing, married men live longer. We should say volunteer, then I'm gonna skip over this, I don't feel like that. Alright, get out a clean sheet of paper, we're gonna go over these problems together. You can add it right to your homework, whatever we don't get through. Just add this to the assignment, but we'll do these problems together. Tonight, is it gonna bother you if I sit down and do this from my seat here? You're not gonna run home and tell your grandma that everything's horrible and then she's trying to do it. How's your grandma doing? Not to be nosy or anything, how old is she?
No, she's older than that. Cause my grandpa was turned 81, so she's close to 80.
Can I ask a question? Is this like, what's this?
Partner.
Like for today or from like?
Both. They're both gonna go together. So if you've already, if you've already started the other homework, you can add this right to it. Alright, so if you've already started, don't waste another sheet of paper. Just add this to the next page or something, but yeah, the other homework. Tell them all your other classes you do work already. Yeah. My son's got 2 math classes, they haven't had any homework yet. What?
Is that?
Didn't they do that last week?
Huh?
Didn't they do that last week?
They start Monday.
No, they're not at home.
You're probably lying, and you told your mom that? No, I don't have
I
to.
went home and did it.
I did my 9
Impressed.
That was horrible.
He has anatomy too. Is that art class? Is it gonna be art?
It's just a lot better.
You know, his anatomy, when I looked at his schedule, it says something like botanical, molecular, something crazy like that. It's got a crazy name.
Ours is not, it's not hard to.
Yeah, I thought, what is this? He goes, oh, that's anatomy. Number 1, how's a sample related to a population? Somebody explain to me how a sample is related to a population. All right. I'm just gonna make it as easy as I possibly can. Part of population. Like it's spelled. So sample is just part of the population. How can we use a sample more than a population?
You pull multiple sections out of the population.
Easy. That's the easiest thing to say. Easier. Sometimes it's almost impossible to get the entire population. Number 3, what's the difference between a parameter and a statistic? Easiest thing to do here probably is that little drawing. Parameter goes with what? Population. Statistic goes with what? Sample. Two main branches of statistics. Just talked about it. Descriptive, what was the other one? Inferential. Probably spelled that wrong.
You're a math teacher, not me.
No, if you spell it wrong, then I'll take off points.
Any way you just-
Determine whether the statement is true or false. A statistic is a measure that describes a population characteristic. False? Everybody agree with that? What's a statistic describe? Sample. Sample is a subset of a population. True. 7. Somebody read that next one to me so I don't have to keep jumping back and forth.
What's that bottom?
Inferential. Yeah, sorry, I'm just writing because I'm very good at it.
Is it possible for the Census Bureau to obtain all the census data of the population of the United States?
True or false? True. I think last time they did a census, they sent me like 6 different things, and they finally started sending people out to our house, and so finally I filled it in and sent it in. Because they send you out stuff, and if you don't send it back, they send you something else, then they send you something else, and they keep it going, trying to bug you, and calling you and stuff, and saying, hey, we haven't got your census, and then finally they start sending people around to the houses of the people who didn't turn it in. And so finally I said, all right, I'll fill it out. Somebody read the next one to me. Yeah, read. What's up?
Inferential statistics involve using population to draw a conclusion about a corresponding sample.
True or false? It's false. It's actually, it sort of says it backwards, doesn't it? If we're gonna make an inference, we don't use the entire population, what do we use? Sample. And then we make an inference about the population. Number 9, what's number 9 say? Read it.
A population is a collection of some outcomes, responses, measurements, or counts that are of interest.
Be careful on this one. True or false? False. Population is the people.
Whoever wrote my book's wrong.
What they were talking about there is let's see, I gotta find it again. The population is a collection of some outcomes, responses, measurements. When you're talking about the outcomes, are you talking about the population? No, the population are the people. What you're talking about there is the statistics or the parameters, right? Yeah, and I think I didn't read all the directions. We're probably supposed to be filling in other words to fix these to make them true, right? I'm not worried about that. So what you would do there is you would take out population and put in parameter, and then it would be a true statement. Number 10 say.
Sample statistics, obtained from sample sample.
That's false. So if I do a sample of you guys are my sample of National Trail, and we take a poll and I say, all right, how many of you drove to school today? So raise your hands, how many of you drove to school today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 5, 11, 15. 11 out of 15. So if we have this, 11 out of 15, anybody have a calculator real quick? You can use your phone. What's 11 divided by 15? How can we change that to a percentage? 0.73. So 73%. Now, if we go out in the hallway and we pick 15 people, or however many people, is it gonna be 73% of them that drove to school?
Probably not.
Probably not.
That's 600 classroom.
Right. Everybody in here is at least a what? Junior. So everybody in here has had a chance at least to get their driver's license, whereas a lot of the people out in the hallway haven't even had a chance to get their license yet. taken away. That's not good. Where's the state erase it? Number 11. In exercise 11.220, to determine whether the data set is a population or a sample. Explain your reasoning. I don't care about explaining it. Let's just go through there. And on a lot of these, again, I don't want to make this harder than it has to be. What could we write to make this easy on ourselves? Instead of writing out population or sample every time, S or P. All right, now I'd be fine with it. The height of each player on a school's basketball team, is that a population or a sample? Population. How come it's a population, not a sample? It's the whole team, all right? And that's the hardest thing. Maybe it's not hard for you guys. It's hard for me. Every time I look at something like that, I think, okay, what are we dealing with here? And I got to really, really think it through. See, and that's what I think too. I'm thinking, okay, we're just taking just these 12 people. I'm thinking sample. But we're dealing with the basketball team, that's the population, because there's nobody else that's on the basketball team. The amount of energy collected from every wind turbine on a wind farm. Population or sample? Population? Because it's all of them on that one farm, right? Now, it depends what we do with that. If we are going to do some kind of inferring to other wind farms, then it would have to be a sample, but since we're just dealing with that one farm. A survey of 500 spectators from a stadium with 42,000 spectators. Sample. 14, annual salary of each pharmacist at a pharmacy. Population, because again, we're just dealing with what? That one pharmacy. We're not dealing with every pharmacy. 15. Cholesterol levels of 20 patients in a hospital of 100 patients. Sample. 16, 17, 18, 19, 20. Hope I don't get any of these wrong. I'm a little stupid on this video. 16, number of televisions in each U.S. household. Sample population? Population?
Yeah.
Because we're talking about all the households, right? Now, would that really be possible? That's what Jesse was thinking. You can't go around to every household and figure out how many TVs they have in it, right? But you could try, I guess, but probably won't work out too well. 17, the final score of each golfer in a tournament.
Population.
How come it's a population? The whole tournament, right? There's more golfers out there, but we're only talking about this one tournament. That's where it is. That again, I get confused there. The age, I wanted to say something smart over there, and I had to catch myself. Got to remember that the video's on. The age of every third person entering a clothing store. That's a sample. 19. Political party of every U.S. president. Population. We're just dealing with all the presidents. There's been what, 42 of them? You guys are supposed to know these things. What is it? Yeah, I said the wrong number thinking that somebody'd say, no, Obama's the 45th president or something like that, but nobody jumped in. The soil contamination levels at 10 locations near a landfill. Because there's more than 10 locations around that landfill, or that landfill, right? But we're only gonna do 10. In exercise 21 through 24, use the Venn diagram to identify the population and the sample. We're just gonna do 21 and 22 together. Does everybody know what a Venn diagram is? Alright, Venn diagram, and we use Venn diagrams here and there and here. Venn diagram, a lot of times it'll look something like this. Maybe this set is, we'll call the whole set A. This one right here is B, and we'll call this set C. A is the what for this Venn diagram? The population. B is a sample, C is a sample. And then what do we know about the things that fall in this area in here? It's a sample also, but they're both in what?
Same.
They're the same, they're in B and C, right? Alright, so that's a Venn diagram. A lot of times the Venn diagrams that we deal with in here will be more like this. That's your main sample. You got that's your population. Then you got little samples that maybe don't overlap each other. In 21, what's the population? The box, what is the box? Warren County voters. Warren County voters, that's our population. My pen would write.
It's actually the whole one.
What's the sample?
The ones that responded.
The ones that responded, that's our sample. So just the ones that responded. And right, that's our sample. About 22, what's the population?
Number of students who did it.
Students who donated. It's our population, is that right? And what's our sample?
Who has O positive.
O positive. Anybody got O positive blood? You do? Isn't that like the hardest one or something, the one that's the most, or the one that's the most useful? O positive is, that's the one you can give to anybody.
Negative.
O negative is?
O positive you give to anybody except an O negative. Well, anybody.
Anyone that's not negative.
Yeah.
Because they don't have the protein.
That was way too long ago.
You guys know that I don't have a clue if they're telling you the truth or not, right?
Give anybody O positive.
It's good to have conversation and at least Grant acts like he knows. I believe you, Grant. All right, the assignment is on page 7, 23 through 48. You might go, if you've already done it, you can just go back over it and check it. Because you said now, hey, I did some of it right, and I heard you say before, oh no, I did that wrong. So go back over and check it. If you did all of it wrong, then just go back and redo it so that you understand it. This stuff that we went over today is the basis for everything. And if you don't know what a population is and what a sample is, and what a statistic is and what a parameter is, when we get to the stuff where they say, what's the statistic for, and then you got to do all this work to get it, well, you're not going to be able to do the work if you don't even know what a statistic is. All right? The parent forms, if you have the parent forms, you can lay them right here. If not, get it into me at some point